Alright, I made some mistakes on this one, so I started over. It does not look all that pretty, but I'm going to just I didn't want to have to rewrite the whole thing. So I guess I'm just lazy. Okay, so vertical asymptotes, we're going to take the denominator. X squared minus 9, we're going to say equals 0. I'm going to solve it for x. Solve it for x squared first, gives me x squared equals 9. That gives me x equals plus or minus 3. So that means my asymptotes are going to be at negative 3. Positive 3. So it looks like that. We are going to have the degree of the numerator is bigger than the degree on the denominator by 1, so we're going to have a slant asymptote. So for this one, to do our slant asymptote, we're going to need to do this with long division, because we can't really, I guess technically we could put in the 3 and see what happens. Let's do that. I want to know what happens. If it doesn't work, I can go back and do long division later. So I did get plus or minus 3, so I'll just pick one of them. I'll do 3. Okay, I know what the asymptote should be, so if it comes out wrong, then I'll know. So we get 1 from here. We got x squared, an x, and maybe I need to do it by both of them. We'll see. Alright, bring this down. We're going to do 3, 3, 9, 9, 27, who cares? Now I'm going to do negative 3. So we're going to go 1, negative 3, 0, 0, 9. That would be my remainder. So there it is. So this would be y equals x plus 0. So y equals x, and that's what it's supposed to be. So there's that. There's that. So for long division, or when I had two factors, I just had to divide them both to get it down to what my equation is for my sine asymptotes. So still, I know it looks super ugly, but we're now going to work on plotting some points. So I'm going to have to use some of this space up here. So I'm going to pick like 2 outside, and at least 2 inside. But I can also figure out what my x-intercept is by taking the numerator, x cubed minus 1, set it equals 0, give me x cubed equals 1, and so that is going to give me x equals 1. So x equals 1 is going to give me an intercept right there. And I can find my y-intercept by plugging in 0 for x. So it's 0 cubed minus 1, and 0 squared minus 9. That's going to give me positive 1 over 9. So that's going to be tiny right there. So from here, I already have 2 points here. I'm going to do one more. I'm going to do 2, and then I'm going to do 3, 4. So I'm going to do 2, 4, and then I'll do 5 because I don't have much space for anything else. And then I will do, let's do one more on this side. So I'll do negative 2, negative 4, and negative 5. Again, lots. So I have space up here. F of negative 5, F of negative 4, F of negative 2, F of positive 2, F of 4, F of 5, Alright, so when I plug this into my calculator, I'm going to get x to the third. So we'll start with negative 5 to the third minus 1. Ooh, I need parentheses around that whole thing. Second inverse parenthesis. Okay, now divide by parenthesis, negative 5 squared minus 9, close parentheses, equals. So that's like negative 7.9. And plug in negative 4. And that gives me negative 9.3. And negative 2. and that is 1.8 positive, and then positive 2, that's negative 1.4, and then 4 gave me 9, and 5 finally gave me 7.8. Alright, let's plot all those points. So negative 5 and then negative 1, 2, 3, 4, 5, 6, 7.9, that's way down here. And then negative 4 and negative 9.3, 7, 8, 9.3, whoa, way down here. Okay, so this thing's going to kind of look like this. So this asymptote would continue this way, and basically we're going to see something that looks like through that point, and then down here, something like that. Then at negative 2, we get 1.8, so that's about right there. So we can kind of see we had this point, and this point. So this is going to curve like that. It's going to curve like that, and we're going to go through that point in the middle. And then over here, we got f of 4 gave me 9. 5, 6, 7, 8, 9. That's way up here. And then 7.8. It's like right there. And so this thing is going to curve up from here and curve out. And our asymptote would kind of go out here. So kind of fell off on my graph here. Sorry, that one's way off this wall. Alright. I got to go quick through these because I got to go to robots. Alright, if you're given an equation of a rational function, how can you tell if the graph has sign asymptote? So the degree of the top is greater than the degree of the bottom by 1. Okay, and then you use synthetic division if you can. Alright, next one, 130 through 133, they're asking us true or false, and if it's false, fix it. So number 130 says the graph of a rational function cannot have both a vertical and a horizontal asymptote. That is false. It can have both. We've had a few. Number 75 and 76 from this assignment both had, no, never mind. We had some yesterday though. Today's didn't have any horizontal asymptotes. Okay, if the degree of the numerator is less than or equal to the degree of the denominator, then you're going to have horizontal asymptotes. Number 131. So I guess to fix that one, just get the not out of there. It is possible to have a rational function whose graph has no y-intercept. So that is possible. We had that on number 84. So that is true, right? If the x equals 0 is a vertical asymptote, then it's not going to have a y-intercept. All right, 132. We have the graph of a rational function can have 3 vertical asymptotes. That's possible. We haven't seen one yet, but it is possible. If your denominator has 3 factors, something like that, it's going to give you 3 asymptotes. So that's true. And the last one, the graph of a rational function can never cross a vertical asymptote. That's also true. Sometimes they cross horizontal asymptotes, but they'll never cross a vertical asymptote. Let me say it one more time in case I said it backwards. Sometimes a graph will cross a horizontal asymptote, but it'll never cross a vertical asymptote. Okay, I think that's it.